Hi all, this is Larry Feldman. Welcome to video 2 in this two-part series on how to implement a joystick in iOS. In the last video we ended by filling in this method, game guts. So let's run it in the simulator and see how it looks. Okay, so you'll notice when I press on this red joystick view controller, it's pressed near the center. You can see that the rocket is responding, and if I press down, it goes down, left, left, right, right, diagonally, etc. So this is looking pretty good. I can also press and hold, and you'll see that the rocket moves according to my finger motion in the red square. So that's looking good too. Now it looks a little bit fast to me, so I want to adjust that. And also, when the rocket goes off the screen, we don't have a way of handling that. So let's take care of that now. So the first thing that we're going to do is put a define in here called scale. Let's make it 0.3, and we're going to scale the velocity in the x and y direction by that scale factor. So I didn't mean to put 0.3 here. Let's use the define, and now let me run it again. And now it's moving a little slower, and obviously you can adjust that scale factor to be whatever feels right to you. So one obvious thing that I don't like is that the rocket is always facing up, and I think it should face the direction that it's moving. So let's implement a method to handle a rotation of that image. So if we go back to the joystick view controller, I'm going to paste in a method here called find rotation angle, and I'm going to explain this part, the second line, which took a little trial and error. I'll explain that shortly, but all we do is we find the angle. If you remember your trigonometry, we take the arctangent of y distance divided by x distance to get an angle. And then we return that angle, and we have to add pi over 2. And as I said, I'll explain that shortly. So let's go back to viewcontroller.m. And I'm going to paste in this line of code, self.rocketimage.transform. We're going to do a rotation on our rocket image. And that's by calling the joystick view controller find rotation angle method that I just showed you. And let's run this. And as I move the rocket, you'll see that the nose is always leading, which is exactly what I want. So that's looking pretty good. So let's take a look at this find rotation angle method in a little more depth. When you take the arctangent of a number on a calculator, you typically receive one answer, the principal value between negative pi over 2 and pi over 2. But since we're supplying the y and x coordinates, arctan2 returns the point on the unit circle and it can be in any of the 4 quadrants, and the answer will be between negative pi and pi. So what's happening is when the rocket is pointed straight up, let me make a comment here. When the rocket is pointed straight up, your coordinates may look something like this. And again, we have a negative y value because y increases in the down direction. And the arctangent of negative 5 over 0, this is undefined, but we can think of this as negative infinity. The arctangent is negative pi over 2. So the answer of negative pi over 2 isn't what we want because the rocket is pointed straight up. So we'd ideally like that angle to be 0. In other words, we're not rotating the image at all. So what we have to do is we have to add pi over 2 to make the correction. So if we get negative pi over 2 up here, when we add pi over 2, we are then left with 0, which is exactly what we want. In other words, when the rocket is pointed straight up, we are not rotating the image whatsoever. So all we have to do is have this pi over 2 correction, and everything will work just fine. So again, if we come back and run this in the simulator, you'll see that the rocket moves and rotates as we would like it to. Okay, one thing I want to clarify here is my comment. This says -5, 0. That looks like standard x comma y, but this is atan 2 of -5, 0, where the y value is first and the x value is second. So just wanted to clarify that. Okay, now we're on to the last step. So I came back to viewcontroller.m and I pasted in this code here. And what we're doing is we're checking to see if our rocket image goes off of the screen. So this first if statement checks to see if the x-coordinate of the center is negative. And if so, we want to move the rocket to the right side of the screen. So if it's negative, it's off the left side of the screen. So what we do is we reposition the x-coordinate of the center to be at the right side of the screen, which is self.view.frame.size.width. We take the y-coordinate of the center and we add the velocity in the y direction. The next if statement checks to see if the rocket goes off the right side of the screen, and if so, it positions it on the left side using 0 as the x-coordinate. And then it keeps the old y value of the center and adds the velocity in the y direction. The next one checks to see if the y-coordinate of the center is off the top, which is negative, and then it repositions it at the bottom. The only thing that I do is I subtract 150 for our joystick view controller. And the last if statement checks to see if the rocket goes off the bottom of the screen, and I subtract 150 here for the size of the joystick view controller, and if so, it positions it at the top of the screen, which is a y value of 0. So let's run this in the simulator. And as we move the rocket around, let's move it off the top, you see that it appears at the bottom. And if we move it off to the right, it appears on the left, etc. So now we have a character that leaves the screen and enters on the opposite side, which opens up a lot of possibilities. You can also put in code that will just stop the rocket at the top and not wrap around. And similarly, we can stop the rocket from going off the left or the right side or the bottom. And that's a pretty easy thing to do. So anyway, that's it for this tutorial. I hope it was helpful. If you have any questions, please email me at lfeldman65@gmail.com or write a comment on YouTube. Please tell your friends and family about my channel. I would appreciate it if you subscribe and like my videos. Lastly, I created a few apps based upon this type of template, and they are listed in the YouTube description, and I have links to my projects on GitHub. So feel free to use them and create your own games. Obviously, please don't copy what I do exactly, but I hope this provides a good starting point for you. Thanks. See you next time.